Ready? Ouais, ça va ce qu'il dit. Hello. Well, assalamu alaikum. Hello. It's design stream. Today, yesterday I had an idea, but I totally forgot what it is. Isn't that annoying? So I added two few things on the new drone, and the things that I need to ask an engineer to confirm me what I'm doing goes in the right direction. I'm just wondering if what I'm doing is possible actually. The things that finding this kind of engineer, because drone is still something very new, and I haven't found a lot of engineer for that. That's why it's annoying. And right now I'm wondering if what I do, I was gonna say worth doing, but it's like everything is worth doing. But so everything is worth doing, but in my case, I'm scared that if I do something, if I model something, that it make it not possible to actually, let's suppose, fly. For example, hold on, this would fly, right? This one would fly, I guess, but this one is specific. I'm not saying it wouldn't fly or anything like this. It would maybe fly, but I gotta think different. I need to not think creative. You know what I mean? I need to think functional. And this is what's annoying because as a designer, you can't think uh, functional everywhere. For example, let's suppose you need to make a chair. Let's suppose you make a chair, and if a chair is is two main target or to be able to sit on, and I mean, it can stand on itself by itself and actually hold someone. It respond to the goal, like. But in this way, if I design something and it's actually not capable of flying, for example, it's pointless designing the thing. I mean, maybe in a game or whatever it will work, but not in this case. So that's why I'm thinking right now. And what you see right there, hold on, I gotta share with you Figma. Where is Figma? Here we go. So you guys now see Figma. So let me take this off. No camera today. I have no shirt, so and I'm scared. I was gonna say scared. I don't want to put a shirt on because it's hot right now. So no camera. So yeah, if I design thing, let's suppose that goes there, and right now we have such a thing. Wait, hold on. Okay, I had it something like this. It's some sort of tube, right? Like this, but it's on the back, and there is a rotor on it. Yeah, there is another brushless propeller. So that means we got four. The thing is that this one is big, this one is big. You see? I don't know if you know what I mean. The thing is that hold on. I got to share something else. I will show you something, okay? It's on give me a few seconds. I can't show this, so we're gonna create a new space. Where is it? Give me a few seconds. I'm just trying to create a new space for the stream. Profile. Okay, we got this. Space name. We're gonna make it. We're gonna call it stream. Okay. Oh, hold on. That's great. So this tab, we're gonna call. We will go on Google Image, and I will share this page with you. Hold on. We're gonna helicopter. What I want to show you is this. That's exactly what I have in mind. That's something like that. But the thing is that, oh, my bad. I understand something now. So yeah, you see, hold on. No, you don't see actually. Let me fix that. Software, not this. Where is it? Here we go. Hawk right there. Okay, so what you see right now is the ID that I have in my mind. So basically, it's not this, but the way mine is working is there is that kind of thing. So this is a real one. You know what I mean? This is flying, but it's not flying only due to that. I think there is something that push her in this. I don't. Wait, hold on. I don't actually. I have no idea if this actually works. I mean, how does it move forward or backward? I'm not sure of that. And I don't know how to make mine to function like this. Oh, that's a horsey helicopter. Really? Hold on, hold on. Gotta check this. Oh, really? So it works. Is it flying? Wait, wait, wait. Okay, this guy is talking. So what's this? So there is two propeller. And is it actually working? I'm confused right now. Oh, it's working. Hold on. But how is it functioning? I'm confused. It's actually oh, that's crazy. Hold on. So mine will have there is no sound, so that's normal. Hold on. Hmm. That's crazy actually. Oh, it can turn. How the thing is that I don't know how it turn. We just see two propeller and it's actually very stable. You know what I mean? You see, quad propeller is very stable. So basically, if you have to choose between two propeller or quad propeller, usually they will say quad propeller because it's more stable. But the one I'm seeing right now is extremely stable. So what makes it stable? That's where I'm confused. Oh, oh, you see, this is, the guy says that it's the max speed it can reach. so it doesn't go faster because it has two propeller. I get it now. I think that's the reason. I will have to rip this body part. Those two plate are causing much more drag. Like, yeah. Oh, it's because of this that it's slower. I get it. Is it going faster if you take it off? Let me see. Oh, and it's actually, wait, hold on. That's crazy. What I'm seeing is crazy. Oh, you see? So basically, so it's saying the thing is that the reason why I want to make it two propeller, it's because of battery. You know what I mean? I want it to have long, very long battery. Like having it 45 minutes, for example, is already crazy, and it's a big thing to have it 40 minutes. Of wait, what is this? Oh, wait, what is this? Oh, hold on, never mind. Uh oh, my bad. And I don't know why this is doing that, but uh, here we go. So let me just place this right there. We have the I like because it seems like it actually corresponds to this. You know, this is a good thing. So this it says that it's hard to control such a drone. Okay, okay, okay. So see that very scaled body approach, blah blah blah. If you're an avatar, this is must have D for you, FPV, blah blah blah. Easy to fly handle super win. Yeah. So you see, it's not extremely fast, so the body will handle minor crash easily. Good for indoor and outdoor film. Cons: if you thought it will be to lift your GoPro, you have wasted your money behind it. You have the things that we are not concerned by this because the camera are in front. And wait, there is a mistake on my drone. I gotta make this different. The front. Comment est-ce que je peux faire l'avant pour que I don't know actually. Wait, I'm thinking. Should this be? Oh no, the camera will be at the bottom. My bad. All good, all good. There is nothing. Okay. So if it was okay, FPV system need ROS and not more than. Do not rely on FPV system to fly it, or you'll be buying a new one soon. Very noisy machine. Only okay. So well, it's the case for this one. Maybe mine won't be concerned by this. Things that I need. Well, anyway, let's keep going. Let's see what happened. Uh, is he? Oh, he has this one. I like to see if he has a second port for this. Does he have a second port for this one? Oh, what is this? Hold on. Ooh, that's the same one without the. Okay. Oh, there is a crash. Ooh, that hurt. It's terrible. Okay, so on this one. Oh, that's very light now. Oh, wait, hold on. Yep. So it's less heavier than before. So let's see. Oh, it's actually nice. That's very quick. What the heck? Oh, this one is faster. Yep. Much, much faster. Yeah, that's actually much faster. Let me see. Oh, I braked it. What happened? Is it broken? But mine won't have this issue because you see, it's not protected. I mean, if you hit something, it's going to break pretty much. But mine doesn't have this issue because mine is protected by this, okay? It doesn't have issue regarding this, except maybe if it hits the top of it. That'd be really, really bad. But let's not think about this for the moment, okay? Let's see. But at least now I know that a plane like this works. But the thing is that it seems like it's balancing life. Like if this goes up, it moves backward, and if this goes up this way, I mean this goes down, it goes forward because it's turning the propeller in certain direction. Let's see right there. And there is another thing that I just realized that I got to fix. I need to make this lower. Or maybe instead of this, we had a grid. Yep, we had a grid, so it works better for flight mode. But for flying, diving mode, we'll have to close this or hide it, or I don't know. There's another problem that goes inside because if you see, if you close this, I think I've fixed it. I'm not sure. I think I fixed it. I gotta check. I gotta check. You see, there is a lot of things that are annoying. Let me see. Um, hmm. I don't know actually. Wait. Let's do something else. Okay. Two propeller drone. Two propeller drone. Okay, let me see what's happening with the two propeller drone. Innovative. Oh, no way. So basic. So right now I'm seeing there is a video that is very old that says innovative twin propeller drone with a new design, more stability. You see, I knew it. I knew it. So basically, I'm a genius without knowing. Apparently, it's more stable. Isn't that crazy? And yep. Oh, I'm actually so smart on what I just did. Because the thing I'm watching right now in the video is pretty much exactly what I did. I swear that's what I did. Wait, 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 wait. I'm actually so smart. I didn't do it on purpose when I did mine. I did it because it seems like not logic, but creative. So let's see, wait. Hold on, let me open link in split view. Okay, this is the stream. And this, hold on. This is what I was looking at. So basically you see it says quad propeller, two propeller, and you see on this one, this is moving thanks to this way, this, and this. Mine will be different. It won't be moving thanks to this, but it will be. Ah oui, mais en vrai, je suis un tueur en fait. I'm actually smart. I did mine without knowing, and it's actually something innovative. Okay, okay, let's go. Let's keep watching. Quad propeller. How is this? Let me see. I just need this for the chat actually. Can I actually hold on? What is this? Oh, that's okay. That's not what I wanted to do. Had the split view. Move to. No, had split view. Here we go. And I don't care about this. Do we need this? No, we don't. Now I need this to be. Hold on. Okay. So this is what it is. So this is a. Okay. This is two propeller. I hate when it translates. That's annoying. Oh, you see? So this is rotating. Okay. Okay, okay. The thing that is nice when it's slow, that means you can have more stable image than if it goes faster. Because if it goes faster, you need something that's stable the image, you know? But in this case, it's actually nice. Yeah, hold on, let me see. Let me see this. So I'm watching stuff right now, as you can see. I'm not designing thing. I'm getting some lesson. That's what I'm doing. Do we have more there? Oh, who wins? Oh, let's see this one. Oops. Okay. Oh, it makes no noise. That's crazy. Ooh, what is this? What is this? Hold on. Wait, let me see. Maybe I should make the same type of. Hold on. Is it? Let's see. Different. Mine are a bit different. Okay, this. Let's see. Wow, there is six. Wait, there is 12 propeller on this one. Okay. It's because it's her. The reason of why it makes noise because it's due to her, and her is touching the propeller, and that's why it does noise. And if it hit it too much, I mean, in a certain way that is not dynamic, you know. You see. Oh. Oh. So this will works better. Hold on, hold on. And is this act that's yeah, you see. So basically what is he saying is exactly what I was saying just 5 minutes ago. That's literally what I was saying. For someone who actually doesn't even design, uh who's not even an engineer, you know what I mean? That's crazy. I feel weird. Wait. Oh. So that means they made a lot of thing to actually make it work. C'est un truc de fou ce qu'ils ont fait. See? I need to send my drone to DJI for real. Just imagine 2 seconds. This shit works. Oh, that's true. There's the propeller actually on top. I can make mine on bottom, maybe. What do you think? We can maybe invert the. I need to make another project with the drone, and actually, I need to do this and make a different version to see what I can do better. Yes, I must do that. So you see on this one, it's a bit different. So, ooh, okay. Oh, what the heck is that? What was that video? Hold on. What just happened in this one? You see how fast it is with quad propeller? You see? That's crazy. The thing is that we need a drone that allows you to actually be noisy or not noisy. You know what I mean? That'd be better. I mean, having a drone that can be noisy when you need to hear it, and one that, I mean, a silent mode that's, let's suppose you lost your drone, and having some sort of signal that allow you to know where it is, that make it different. So, I mean, this drone is massive. I mean, it will never deliver like as a truck can do, you know? maybe if we have the things that we need a local, uh, like a local place where this thing drop it in a place like something that is standard. You know what I mean? So basically, you have some sort of house or place where this drops all the delivery, all the packages for the people, and people just go like a retail, and they just pick it up, and that's all without having people like, and you unlock it with how it's called, with a QR code, for example. That makes more sense to me, and it will be faster. I'm sure of that. But I think that there is a lot to design on all of that. You gotta make specific route. For example, like flight, like plane has specific route. They can't go in certain place for many reasons. It would be the same for this. You need a route in sky, but that's not the biggest thing. I mean, the thing is that those one are very small. Like it will never. I mean, if it's small, that means it will be expensive to deliver. I mean, it will be more expensive to deliver at your home. You know, that's why it's weird. What's this? Wait, hold on. I need this. Open link in split view. Ooh, what is this? Oh, there is no. Okay, I get it. Let me see this. What's this? I don't care. Can I have some? Ooh, wait, hold on. What is this? So you see, okay, not this. What is that? Okay, this is interesting. That's terrible, but it's interesting. It's heavy and okay. Not fan of this concept. What is this? Okay, this is more interesting, I think. Yeah, I think this one is the most interesting one. This one, yep. Is it noisy? What's this one? Oh, that's massive. What is it? Is that a plane? Mais c'est quoi ce truc? Wait, I'm very confused. There is no way this shit goes that fast. Hold on. Nah, that's not possible. But the movement it has is crazy. C'est impossible que ça va à 130 ce truc. Je fous de ma gueule. What is this? Ooh, this seems very. Ooh, that's yeah, that's a good one. Just by the shape of the whole body. Yeah, that's a good one. You see, it seems like military, like some sort of super drone, you know? Yeah, you see, and they're making it like it's F1 race vehicle. Yeah. Yeah, you see. Wow, that's actually fast. I mean, they made it faster when you see jet and stuff like this. But this is some sort of car, if you know what I mean. This is actually crazy. This one. These are like cars, if you know what I mean. I mean, you need root, but it must be something very stable. The thing that is annoying. Wait, this is You see? Oh my god, that's crazy. 100 kilo, all of this, without counting the guy that is inside. That's crazy. It's the thing. So basically, to have something that is stable, you must have good material. And I mean, it can't be cheap and fly with someone inside. It must have heavy material. Having something stable is so it got to be stable, not heavy, and almost emitting no sound. You know, and this is hard to do. Most of all of this stuff make crazy sound. It makes a lot of noise. So this is interesting, but it's still massive. Like it's crazy massive. What is this? Kerosene. I think it's better if it works on kerosene because. Ooh, what is this? Hold on. Yeah, that's a good one. Let me see this. That's a bike that is flying. Oh my god, that's crazy. Yeah, that's crazy what it did. Oh, you see, that was solid work. I think. Yeah, I think it seems like solid work. I think the software, even the concept, it's very solid. Let me see. Oh, that's crazy. Yeah, that's insane. Actually, I wonder how. Oh, France. See, that's the country. France, frérot. It's not expensive for what it is. You know what I mean? What is this? Oh, this must be extremely expensive, especially if it makes no sound. Like, imagine like just saving people like that. You know what I mean? This is for emergency, especially if you can hold another body on it, like saving someone in the mountain or whatever. This is crazy. But you must be a fucking nice pilot to actually have this. And what's this one? Oh, what is this? That's a jet. There is no way. And he has nothing on his hand. Yeah, that must be extremely fast. Trust me, this is fast. Yeah, I knew it. So basically, that's the power of a jet on someone. Yeah, you see, flight time 13 minutes. Because it's electric or what? Is it? No, that's not electric. This is kerosene. Man. Oh, that's crazy. What the heck? Oh, you see, they get rid of something crazy. That means this is a lot of engineering. Like it's crazy. I wonder the speed of this. It's kerosene. Oh, look at this man. Oh, it can't land. When it's off, it doesn't. Ça plane pas. C'est de la merde un peu. Hein. Bon, c'est déjà bien en vrai. Hein. So it works. Wow! You see that? That's a Bugatti in sky. For real. See this? Top speed. 400 kilometers. That's crazy. Oh, there is no way they did this. And you see, this was 5 years ago, right? And it goes high. I like this vid. So this was 3 years ago. Imagine what they can do now with AI. They can speed up everything. Oh, that's crazy. Just imagine you're in the plane and you see this. And you know, every time you see stuff like this, they're going to make it military all time, all time. This kind of engineer, they make it for war. That's annoying. There is two guy. That's actually funny because this is literally two guy. Oh, what is this? Oh, okay. Is he actually flying? This one is probably the best one on this. Oh, come on. Oh, hell no. Hell no. You see, everything that is too advanced goes into military all time. That's annoying. But that vid is crazy. So we were on this and I was supposed to look this one, right? Here we go. Okay. Okay, the design. Okay. I need to do this. This is what I need to do for mine. Yep. This makes a lot of sense. What you just said makes a lot of sense. That means the hair doesn't go there and doesn't block uh, the rotation of the other propeller. That means it goes there, but it's passing, you know what I mean? It goes there and this one goes there. It's not blocking anything. Okay. Yep. Turbulence, exactly. Yep. Let me see. Yep. Less turbulence, less noise. That's exactly what I was saying. That's crazy. Let's go. Oh, yeah, it's the weakest material, he says. But if it had a crazy design that, I mean, for the air, you know what I mean? It wouldn't destroy like it just did. You see? I think you need. That's weird. En fait, c'est bizarre. Si, en fait, c'est le matériel, mais ça pourrait marcher si il y avait des frottements de telle sorte à ce que les frottements ne brisent pas les hélices comme ça, en fait. Soit tellement dynamique que ça brise pas les ailes, même avec un matériel qui soit très faible, qui soit pas résistant. En fait, c'est parce que sur son drone, je crois, oh, yeah, you see, flat, strong, standing, weak. Maybe I should put the sound on. Yeah, I'm gonna put the sound so you hear what he's saying
use like a
because that's
electric
really
filament,
important.
but that's a little more time I don't want to spend on
So
this
hear
batch.
that.
So what we're going to do is use a process called annealing, where we actually try to kind of melt the layers together a little bit and help them be a little more durable. Oh, and this is our annealer, the Ninja air fryer. This should work pretty well. Got to make sure these all point down because the blades will like, if they're pointing straight up in the air like this, they'll probably bend over. That'll go all the way to
So you need to
195. I think
bend
this
them
is an
to
hours thing, so
improve the
let's take
dynamic of
this
it,
down to
right?
like 2 hours. The air fryer just finished up. Let's see how these guys turned out. Oh, I think we have one failure. It looks like one of these rotated while it was in the air fryer. But yeah, the rest of these look pretty good. And while they're still warm, you can actually adjust them. Yeah, they still bend. if they're a little crooked or anything. For Dremel, we can easily shave off the weight needed to balance the prop in any direction. For the sake of 3D printed props, we're not going to need to get as detailed as we might with a normal prop that you would expect to last for dozens of flights. Fortunately, if these props don't last, we have backups already printing. Oh, there they are. Those look, well, pretty good. Looks like we had a little bit of a bubble right here, which could be a problem. That might split a little easier than we like, so FPV drone with 5-inch props instead of the 7-inch quad we started with.
Maybe I should do this for mine. What do you think?
And should, in theory, be more likely to survive.
Wait, did you do that? We
also went with a smaller pack to decrease, but this is more about whether this can actually fly anyway. So what we've done is set up a couple GoPro cameras, so you can look over here. We have one GoPro on 240 frames per second. Okay. So I think that's all we're going to do.
Let's make it faster. It's too slow.
Plug this thing in and see what happens.
Okay, that's much better.
The annealing makes a big difference usually, but I don't know how well it's going to fly or for how long. So let's power it up. All right, moment of truth. We're going to see if this actually works. The last couple tests haven't been so good.
En fait, il y a des vidéos, elles sont tellement longues, je m'en speed. C'est trop. Qu'est-ce qu'il a fait?
We have more work to do. Every
flat printed props. Okay, let's see.
Unfortunately, 3D printers aren't really optimized for this type of print unless you use supports. This means more prep and cleaning of the props, and a final product will be less smooth and more noisy. However, this will make them stronger. We are going to stick with PETG since it's more durable than PLA, and we're still going to anneal the props to increase the bonds between the layers. Fortunately, Ohio and its meteorological mood swings are currently in our favor.
Ooh, hold on. It is much better.
While this might seem obvious to you, printing them flat makes a huge difference. You also notice the sound of the props is lower pitch. Quieter? Not really, but the concept is there. I'm just glad that the dozens of hours of work, testing, and redesign have finally paid... Oh, crap.
That's unbelievable. I think you need to make wall on it so there is less resistance, you know?
The motors are surprisingly cool. Now, I did not run it very hard. That was actually just kind of...
You have this in car. Some car has hole on it.
It actually held up really well. Now, granted,
like Ferrari, for example.
It flew, and it definitely sounded
for
very
airflow.
That's impressive. So, maybe try Avata. And speaking of the Avata, there is even a tiny, cute little Mark Rober zip line, if you will, prop for the Avata. The blades probably need to be a little bigger. I don't think they're going to catch enough air.
But the thing is that the one he designed them without engineering, without simulation. Nothing, like I'm doing right now. So it's just trying to copy what the zipline did, and it's not working.
This is the sound of a normal propeller.
So I need 2 propeller. Oh, I've seen this one, that's crazy. I need... So you see, that's what I was saying. You see, it has 2 propeller and it fly during 50 minutes. That's crazy. And it was 4 years ago. So having 2 propeller is extremely interesting. Oh, what's happening? I need to see this. Did it actually put in? Oh, there is no way. Just for this. Come on. He panicked. But he got it. Bend it. Ooh, what is this? Wait, what is this? Oh, we already have it in my drone. No worry. I just didn't design it all around, but we have it. So, what's this? Tricopter. What is this? Oh, it's 2 propeller and the engine at the back. Let me see. Make it slower. Let's see the real speed. Oh, what is that? Oh, we're gonna have this thing at the back on mine. What do you think? like a real manta. You know what I mean? If you pay attention to manta ray, there has this kind of thing. If you pay attention to a manta ray, you have this. So yeah, you have this, the body, and you have something. There is a tail on it. I don't know if the tail has any. I mean, I don't know if the tail is actually involved in the direction or not. I think maybe. Who knows? Because in plane it does. Maybe this. That's crazy. Come on, quantum system phase. What is this? We can make my drone like a ray manta. Like it's actually looking like a ray manta. That's what I did at first. But it has no tail, you know. Mine has no tail. I bought a cheap drone propeller from AliExpress. Ooh, what is this? Let me see this
Here
one.
we have 6-bladed propeller, and the rest of them are 2-bladed propellers.
Well, that's crazy noisy.
Silent.
Ooh. It's less noisy, yeah? Fine, okay. 2-blade versus 3-blade. Oh, that's actually...
Which propeller should you use, 3-blade or 2-blade? In this video, we will put the leading 3.5 motor at 1404 or 1300 kV propeller comes in at
That's interesting.
1.02 gram savings across 4 propellers. We can see in blue it across the
Okay, I don't need to have too much detail. I don't need Fury. I like
It does
Fury
help
is nice, but I need
to see how they
simulation.
performed and felt
Let
in
me
the
see.
2-blade. Yeah, the additional thrust at the top end.
Hmm. Okay. Thing is that it's still something very new, and it's something that is very new. Oh wait, what did it just do? Oh, modulable. Really? Okay. Oh, that makes too much noise. Oops. The noise it makes is crazy. Okay. Drone experiment. How to make drone. Okay. En fait, c'est pas évident, hein. Okay, let me see this. What is this? Oh, never mind. No, you see, even there's not much people who do drone with just 2 propeller. That's oh, what is this? Oh yeah, that's the fly caught. That's the one I was looking at. So he's making his own drone, you see. this video.
From the comfort of your home. Receiver, a 3-gram FPV camera, a LiPo cell with connectors, parts for holding things together including popsicle sticks if you choose to make the wooden frame, or PLA filament if you choose to 3D print your frame. All parts and supplies are listed with product links in the description below this video. To make the popsicle stick drone frame, we'll print out the blueprint sheet for the wood and rubber cutouts. A free resource file I came up with which you can download from...
Nope. Oh, you see, this has 6 years. Ooh. I need a video from this year to see how to make making a double propeller drone. Ooh. That's what I like to see. It has a battery. Okay.
This is a 3D printed mold of a propeller that I can use to make professional plastic parts. The way it works is, I close the mold and inject hot plastic into this hole using Injecto. To do that, I first place the mold in a vise and close it really tight. I then place the injection hole in the nozzle and press the green button to inject the hot plastic and the red button to lift the injection ramp. The result is this super professional part that I can now mass produce. It also just pops right out of the mold, so
Why
I can keep making
didn't he
more.
made a
I'm
ton of it
super
so he
excited to
has
try this prop on my drone.
multiple?
If you're interested in making your...
Oh, come on. Okay. I need a double propeller drone, please. Is anybody doing a double propeller drone? I've already seen this one. Yeah, I did. Okay. Wait, without flight controller, really? Okay. Oh, it goes inside. These guys are crazy. It's actually going to fly, trust it. It's not. I thought it would.
My prop is broken, so I have to try.
Ah. I can't find self-made drone with 2 propeller. I only see quad propeller drone made by people, and even those who are actually made, they are in demo version. I mean, there is nothing. Oh, that's crazy, the shape we have on this. Nope. Come on. So basically, dual motor drone. Okay, let me see this one. I thought it was a quad one. It's apparently
एल्युमिनियम का एक फ्रेम वो का
no sound, please. Come on. So I'm just looking at the inside. I don't care about the outside, because if it's flying this way, okay, that's the motherboard for it. For this one, I don't know what it would look like from a DJI one. Let me see, a DJI motherboard. Oh, I've already seen it actually. Yeah, I've seen this one. But what does it look like? You need a PCB designer to actually make it. Let me see. That's the motherboard right there. Yep, come on, play. So this is a motherboard. So I gotta make something like this that is not functional, just for the for the design. The things that the drone I want to make, like most of people who do drone, they just make it the inside and the outside is terrible. It's not good looking design. And they just want it to fly and maybe have a camera and blah, blah, blah. And me, that's not what I want to do. I want to have a beautiful drone that is both functional and good looking. I don't want just a terrible design drone that fly. It's not what I want. But if it's possible to make, I don't know. We will see. We will see. So we keep working. Oh yeah, I've already seen this one. Yep, yep. So what did he just do? So this is the motherboard. Oh, there is this. So which one is the motherboard? This or this? Oh, this one. I think. Yeah, that's this one. Oh, that's a controller. That's the flight controller. This is the motherboard flight controller, I think. Yeah, if I'm not wrong. Si je me trompe pas. Hein. Okay. Drone motherboard. Full. Ooh. Wait. Fully open source. Really? You can do that? Come on. Fully open source. So you can make it from A to Z. Oh, that's the PCB design. Yep, see. So hold on, let me take this off. So you can design it on. Okay, so I don't know if you made this. I don't think you made this. Then. Okay. Uh-huh. Oh, that's the command. Oh, you see. Quadcopter drone. Oh. Okay, let me see the second video. Zero, you can build your drone with less than 40
to
components.
build your own quadcopter. In part 1, we already discussed the major components that are necessary.
Well, mine
This
will have
quadcopter
two
consists of
propeller.
38 unique components, and in order to be able to test everything, you will need 7 additional components.
Okay, so what are the components? Because the thing is that I asked ChatGPT what would my drone need to have, like both accessory and component. What do I need to do? I asked already everything I need to buy to make it. It's quite
except
expensive.
for the lower and the upper quad.
But the thing is that you see this kind of thing, see this. There's a lot of things you can print and that reduce the price of it. So
Quadcopter frame. Both frames are tailor-made for this project and are actually just printed circuit boards. The printed circuit board material is a perfect match.
I can't do
for
this.
small.
For example, you can print it, but I can't do this. This is something specific. So for the PCB design, must be from a website. I can't do this. Like I can print the form of it, but I can't like have no idea what's happening on the code. I've seen the process, but I have no idea how it's done.
It is light and sufficiently flexible,
So you
meaning that
see, look,
powertrain components.
there's
In
just
part
root.
10,
You see, this is electricity system. see right there.
We already explored the full electronic schematic for the
See,
quadcopter.
so this is the electronic. So this thing repeat 4 times, 1 time, but on my case we have it 2 times.
This schematic is converted in the printed circuit board of the frame. The white, red and blue lines are the power distribution traces, which distribute the energy from the battery to the 4 electronic speed controllers. The smaller traces link the electronic components to each other, enabling the transfer of data. Quadcopter frame. The number of traces on this frame is significantly less because the PCB that I designed for this project is able to accommodate motors with a 3 to 4 inch propeller, giving you some freedom to experiment with different motors and test on the open source hardware lab through the link on the screen. Later, to go to File, pricing for prototype PCBs. 5
I know
lower
about this
quadcopter frames
website.
will only
I found
cost
out
you
another type of
$14.
website.
Evidently, it will include a barometer and some screws and nuts to fasten both sensors. This list of parts with a load limit that matches the maximal current.
Things that, you know, he's designing this, but he's designing this as a user, you know what I mean? He's not designing this, like, let's suppose someone who will do this will make different part, like, let's suppose, let's take a quick example. Someone who has no idea of this will make the first propeller, then this one, this one, this one. It will make 4 pieces. But someone who think about ergonomy and accessibility or whatever, like to make it functional, he's gonna make it in 2 pieces. He's gonna make this and this combined, this and this combined, and this not only for the propeller. He's gonna make it for absolutely everything. If he can have one thing in a single piece, he's gonna make it to reduce the space, to reduce the price of material or whatever.
Drawn by the motors.
And
as
this is what
already
happening in mine.
Propellers with a diameter of up to 4 inch can fit on the quadcopter frame. If you choose to use GE-PRC motors, the fastening screws are included in the package. In the table displayed on the screen.
So you see this guy is placing screw, but if a designer is able to actually make it clipped in it, he's gonna make it. If it allows him to reduce the material of it, that's perfect to him.
The options for 2 GPRC motors will be too high, and both the motor and ESC will overheat. This is evident for the 1105 motor, a 4-inch pair 6 charger, together with a radio transmission of 2.5 by 3.4 I was referring to earlier is now
it's
up and
too
running
slow.
as well. You will find
brother.
the links to all videos and the code into a different type of light controller.
Okay, anyway.
Welcome to this video series, where you are going to learn how to build a production session. Its major component the pigtail for the battery. Without the battery, the quadcopter weighs around 175 grams or 6.2 ounces. Including the battery.
This is the second thing that is important, the weight of it. Because as you know, there is some norm you gotta respect. It has to be under 250 for it to be able higher than certain meter.
The weight comes in just under 250 grams. Thanks to its small size, this quadcopter is capable of flying both indoors and outdoors. A quadcopter relies on 4 motors to receive. Let's now open the Arduino and install it on your computer. ERC website. And save the file under the name Blink. TNC. Connect the TNC again with the computer. Welcome to the second part of this video series, where you learn.
Wait, take a brush. Okay, this.
Welcome to the 6th video in this series. The radio system, battery, motor.
Okay. That's a nice way to explain this. Okay, this is much better than past sketch. So what do we have? So this goes. So this. Okay. En fait, ça fait quoi? Ça fait. Ça c'est la dernière étape. Mais ce truc-là, il se connecte où?
An electronic speed controller.
Let's start by having a look at the motor you will use. A tiny brushless GE-PRC motor.
Okay, let me see
Screws to
this.
fasten both the motor to the frame. 150 grams of truss, meaning that 4 motors will easily be able to lift your quadcopter. Slide the 3-inch gem fan propeller down the motor shaft and push it firmly on the top of the motor. Use 2 of the longest screws to fasten it.
Okay.
Next, cut the white connector from the 3 black motor cables, as you will not use it. Strip each cable carefully, such that you can solder them to the frame later on. The wires are very tiny, so it could take some attempts to get this step right. Attach the motor to the quadcopter frame with the 4 shortest screws. Make sure that none of the screws touch the motor windings to avoid damage. Attach the quadcopter frame firmly to continue by connecting the motor via the ESC to the battery connector.
So
you can use wire terminal strips for the temporary connection, still switch it later. In this case, you have a transmitter in order to enable both to the receiver. This channel corresponds to the position of the left stick on the radio transmitter. Turn on the power button of your radio transmitter while simultaneously holding the bind key button. The text RX binding should be displayed. Now connect the bind plug with the B/VCC pins on the receiver. Make sure the left stick is in its lowest position to avoid a sudden start of the motor. Connect the battery with the XT60 connector to power both, indicating that the receiver indicates you are now controlling the motor speed from channel. You are now controlling the motor speed from channel 3 to start. Now gradually increase the left stick to start the motor. You are now controlling the motor speed from channel 3 of the transmitter. One thing remains to be done. You have to tell the ESC what the upper and lower position of the transmitter stick corresponds with. Once again, this is a form of calibration. Let's proceed. First, make sure your battery is not plugged in. Turn on the radio transmitter and put the throttle stick to its uppermost position. When connecting the battery, this makes sure the ESC goes in programming mode. After connecting the battery, you hear one beep from the transmitter and subsequently some beeps from the ESC. Move the throttle stick to its lowest position between the first and the fourth beep. After 2 seconds, the ESC should give 2 times 2 beeps, indicating that calibration is finished. Increase the throttle stick to start and control the motors. When you get a linear behavior from the lowest to the highest position of the stick, the calibration was successful. You should calibrate your 3 other ESCs following the same steps. This is necessary to ensure a smooth flight later on. In the next video, you will learn how to connect your receiver to your TNC and read the signals from your radio transmitter. You are watching the 7th video in the series that explains you how to build your own quadcopter. In this video, you will learn how your TNC microcontroller can receive commands. We are rapidly electronic speed controller, or ESC. ESC does this by opening and closing the connection between the battery and the brushless motor, hence controlling the average voltage provided to the motor. You can control this average voltage through pulse width modulation. This means you only need to send a PWM signal from TNC to the ESC in order to control the brushless motor. This is also the reason that each motor needs a separate ESC, since you need to be able to control the speed for all motors separately. You will recycle the circuit that we already built in part 6 and use the same TNC receiver setup from part 7. The ESC needs to be connected to a TNC pin that is able to send a PWM signal. You will use pins 1 to 4 to control all 4 motors. For this example, connect the white signal cable of your ESC to pin 1 of the TNC. The 5V and ground cables need to be connected to the TNC 5V and ground pin. Notice that your ESC will transform the battery voltage to a constant voltage of around 5 volts. This means that your TNC will be powered directly by the battery. The schematic of the setup used in this video is shown on the screen. It begins to resemble the final electronic schematic that we are working towards and that will be necessary for full quadcopter control. Let's start from the circuit built in part 6. Disconnect the receiver from the ESC. Use 3 male to female jumper cables and connect the white signal cable and the red and black power cables to the PPM channel of the receiver. As already explained in part 7, you need to connect the white cable to TNC pin 14 and the red and black power cables to the 5V and ground pins. Now use 3 male to male jumper wires to connect the ESC to your TNC. Continue with the probe and PWM signals
so this goes
for a frequency of 200.
Where is this?
Connect the battery. In order to hear the starting beeps from your ESC, remember that you need to move the throttle around its lowest value for the code to continue. You are now ready to start the motor. Increase the throttle to test your electronic circuit. Congratulations, you succeeded in controlling your motors through your TNC microcontroller. In the next video, we will explore how you can manage the battery of your quadcopter. Do not forget to subscribe if you like. We arrived at the 9th video in our series, in which we will have a look at a very special transistor enabling you to act, which will enable you to take the battery management of. I will discuss with you the capabilities of this transistor, which will enable you to take the battery management of your quadcopter to a new level. Remember the relation between the battery voltage and the remaining battery lifetime discussed in the 3rd video? A linear regression of the middle part of this graph allows you to estimate the remaining battery. With all ingredients for a control system together to be able to, will have to work at around 50% of its power as shown on the figure. To increase the altitude at which your drone is flying, you simply increase the power of all 4 motors to, for example, 75%.
In order for the quadcopter to stay level, it is important that all motors increase their power at the same time. The command that keeps all motors at the same power level to control the altitude of the quadcopter will be called the throttle input. When you want to change the direction of your drone, things become more tricky. Assume you want the drone to stay at the same altitude, but move sideways to the right, which is a roll around the x-axis. The throttle input will be equal to 50% for all motors, as you do not change altitude. But in order to initiate the sideward movements, the power output of the left motors, which are motors 3 and 4, should be higher than the power of the right motors, which are motors 1 and 2. This means that you need an additional roll input, which will lower the power of the motors 1 and 2, with for example 25%, and at the same time increase the power of motors 2 and 4 with 25% as well. With the same reasoning, you can estimate the motor power for a pitch movement. In this case, motors 2 and 3 will need to work harder than motors 1 and 4. Just add 25% power to motors 2 and 3 and subtract the same amount from motors 1 and 4. The final possible movement is a yaw turn around the z-axis. In this case, the motors that spin in the same clockwise direction should reduce power. This might seem counterintuitive, but the resulting torque on the frame is always the opposite as the spinning direction of the motors. When the motors spin in a clockwise direction, you will get a counterclockwise torque on the frame.
To understand
Therefore,
this better,
to do a yaw turn, you should reduce the power of the motors 1 and 3 and increase the power of motors 2 and 4.
I haven't designed.
A nice property of this definition for the throttle.
I need to build a small one so I know what I'm actually
your drone will be, but also
doing,
you know. For now, take the limit values of 75 degrees per second and
to realize the amount of work.
Thank you for watching this video, and do not forget to subscribe if you want regular updates.
The things that I need more explanation from someone who actually draw. I mean, who actually, I was gonna say draw this, not draw, but who actually create stuff like that. So
we arrived at the 9th video in our series.
Oops, hold on. You make a drone, right?
No.
You shall get no mercy then.
Hmm?
Oh, come on, that's not what I'm looking for.
We arrived at the...
Which one to use? Ooh, what is this? Hold on. I need to find out a good looking drone. So basically, you see, it's a high-end drone, but it's not what I'm looking at. I mean, maybe it goes fast, but the design is terrible. So you see, it's a lot of people doing... Wait, what is this? Oh, that's crazy. I need to find one who designed a drone that is actually looking good. You know what I mean? Even though I don't care, because I know that the one I'll make will be looking good. But there's a lot of thing going on. Drone coding. Ooh, hold on. Give me this. Here we go. That's perfect for me. So it lasts 3H. Learn drone coding. So everything ended up needing code all the time. Come on. There's this one that seems to be interesting. Okay. I need to do a lot of documentation for this. Flight controller. Ooh, that's what I need. This one. Here we go. Oh, what is this? Oh, that's not a good thing. Like, imagine you build a drone and its design, I mean, its concept ended up in military killing people. I mean, just imagine. That's a terrible thing. Like, so we gotta watch which video it is. This one is going to get terrible. Trust
The
it.
term drone means a continuous low humming sound. Now, this might not be the best way to represent these unmanned aerial vehicles, but still it's the most commonly used term. Drones have gained a lot of popularity over the past few years as the technology has advanced and the motors have become cheaper. This has allowed the drones to be used in much more commercial sectors such as photography, filmmaking, surveillance, and even delivery systems. In spite of this, drones have a long way ahead. So learning how to program a drone to perform different tasks is becoming an increasingly popular skill.
Yep.
Drones come in different shapes and sizes. A popular term you might have heard for a drone is quadcopter. This refers to a drone with 4 propellers or motors. Similarly, a hexacopter has 6 propellers, and a
What
octocopter
about 2?
has 8 propellers.
He's not showing 2. Come on. I mean,
So
if you know
let's have
to
a
do
look at the main
4.
components of a drone. A drone will consist of frame, motors, propellers, electric motor controller, power distribution board, a flight controller, battery, receiver or Bluetooth, a camera, video transmitter, and some sensors.
Okay.
The frame or the body is what holds everything together.
Okay, this is a good video to
since
have.
it is quite lightweight and strong. Nowadays, a lot of DIY drones use wood and 3D printed frames as well. Motors can be considered as the engine of the system that creates the lift and allows the drone to fly. There are 2 main types of motors used in a drone, brushed and brushless.
Okay.
Brushed motors are simple and cheap, whereas brushless motors are expensive but have a better weight to power ratio.
Ooh.
Propellers are what generate the lift force when the motors start rotating. There will be 2 types of propellers for any given drone. One that rotates clockwise and the other that rotates counterclockwise. This is because if all the propellers are rotating in the same direction, the drone will start rotating as well. But since we have half of them rotating in one direction and the other half rotating in the other direction,
so what about 2 propellers? How do I make
the drone
it?
does not rotate. Propellers can have...
Wait, hold on. Oops. Need to turn it off.
The electric motor controller, or the ESC, is what controls the speed of the motors. They convert the DC signal from the battery to AC signal for the motor.
Okay.
There are separate ESC for each motor or a single board with multiple ESCs on it. Power distribution boards allow battery to power all the components, including the motors and the flight controller. The flight controller is the brain of the system and it decides what should be the speed of the motors based on the input received from the sensors and the receiver.
Okay.
The battery will power all the components of the drone. This has to be light and efficient at the same time to
Light. So it must be light battery. But if we reduce the weight of all of the components, it can be maybe bigger battery. So, faut faire des sacrifices.
The receiver or the Bluetooth allows transmission of the signals between the remote and the drone. Most of the time,
There's mine right there.
Along with either an SD card storage or antennas for wireless video transmission.
Mine right there is...
Video transmitter. This device is responsible for the transmission of video through the antenna to your cell phone or the FPV remote. There are multiple sensors attached to a drone. For example, the pressure sensor measures the altitude or the distance between the ground and the drone.
Okay.
This indicates the position of the drone, whereas an IMU measures the acceleration and the angles at which the drone is.
Okay, so not all of them is important. How does a drone fly?
The movement of a drone seems quite complicated as it has 4 or more motors to enable all movements. But in reality, it's quite simple and intuitive. The
okay.
drone can move with 4 degrees of freedom, which means it can translate in 3 directions and rotate in 1. As mentioned earlier, 2 propellers rotate in clockwise direction and the other 2 rotate in the counterclockwise direction. This generates a zero angular momentum that allows the drone to stay stationary rather than rotating.
Then what about a 2 propeller?
Look at the translation movements first. First, we will run all the motors at the same speed that will generate the lift greater than the weight of the drone. This will cause the drone to move up. This is the first translational movement. If we want to go down, we will decrease the speed of all motors so that the lift is less than the weight of the drone. If we want to hover in the air, we will change the speed of the motors so that the lift is equal to the weight of the drone. This will allow the drone to hover above the ground. Now coming to the second translation, if we want to move left, we will reduce the speed of the left motors and increase the speed of the right motors. To move towards the right, we will decrease the speed of the right motors and increase the speed of the left motors.
It's crazy what they do.
Similarly, we can translate in the third direction, which is moving forwards and backwards. By decreasing the speed of the front motors and increasing the speed of the back motors, the drone will move forward. For moving backwards, we can decrease the speed of the back motors and increase the speed of the front motors. Since 2 motors are rotating in clockwise and the other 2 are rotating in counterclockwise direction, we can use this knowledge to rotate our drone. To rotate the drone clockwise, we will decrease the speed of the motors moving clockwise and increase the speed of the motors.
Make it faster. It's talking too slow.
To rotate counterclockwise, we will decrease the speed of the counterclockwise motors and increase the speed of the clockwise motors. Now that we understand how the drone flies, let's have a look at the drone we will be using for this course.
Telodrone.
The drone that we will be using for this course is the Telodrone. Now, this drone is recommended to be used with this course, but that does not mean that you cannot apply the same techniques to other drones. In fact, 80% of this course is applicable to any drone and only 20% is specific to the Telodrone. The Trello drone is produced by the company Rise, and it contains DJI and Internet technologies for flight control. It is
Oh,
a
really?
drone with a camera attached to it that can shoot up to 720p video at 30 frames per second. It is
I will check after on. Anyway, let's keep.
easy and safe to use indoors because it has multiple safety features.
Ooh. Okay. Hold on. I will turn off the stream because I got stuff to do. And because I'm tired, I will keep watching this. I mean, turn off this and switch back to this. Okay. But I still need to. That was extremely good to know. Wait, hold on. Why does it say a name? Wait. It says on my stream that it's a name stream. What the heck is that? That's not a name. As you can see, first step, second step, third step, concept, made, another render with a logo. Yep, that's a logo. At first it was, yeah, that's a logo, okay? And OC controller, but that's not the first version of it. First version of it is right there. Here we go. That's the first version of it. Then second, then third, fourth, fifth. And then we made this one. That was big improvement. This one. And then I went to model this one. That is, in my opinion, the best one. Makes a lot of sense to me. But I don't know, maybe even this one is great to me. Like this one. But this one is even more better. Maybe there is some stuff I will get rid of, but for the moment, I like what this one looks like. Okay, anyway. Oh, I have a better idea actually. No, never mind. Let's not do any change for the moment. And yeah, you see, and this is the UI system so far. This is what we have. I don't know if I show you, for those who never seen it. Those who never seen it. So this is what it looks like so far. As you can see, what do we have? Boom. It's like this, Academy. Boom. That's a screen. Boom. Bigger screen. You can see right there. Move back. Boom. Camera setting. I need to change this, of course. Boom. We do this. Here we go. As you can see right there. Boom. Here we go. Boom. And now this should be right there on the screen. Right here, okay? Should be like that. Not exactly like this, but you get me. We have the drone and blah, blah, blah. What's this? Oh, hold on. Responsive. Okay. I don't want it to be responsive. I just want to get rid of all prototype. Okay. So anyway, go. I can maybe make a button to this. Small 28. Slow 800. Here we go. Yeah, that's better. Anyway. That's what we have so far. And here we go. Nothing in the chat. Ooh, ooh, ooh. Yep. So far, that's what I'm making. I don't know which 3D printer I should take. I don't know. Any idea? Not any idea. Follow word. Eating the pain. Exactly. Ooh. Eating the pain. My gym made me want to do push-up. Yep. Let's go. Never stop. Every single push-up is a blessing. So it's time for me to do push-up, guys. Eating the pain. Well, thanks for watching and see you another day. I don't know. Let's do push-up, motherfuckers. Let's go. It's time for me to do